Hey, this is Mr. Scott. I'm just going to go over how to do some gas stoichiometry problems. Some of you remember stoichiometry, and you remember doing that as the first unit of second semester. So as you take a look, this is on page 9 in your packets. All right, so if you want to get this out, I'll give you a second to get your packets out. Okay. But the idea is remembering how to go from using a chemist's balanced equation to go from moles to moles, or to go from moles of one substance to number of particles of one substance, to go from moles to molar mass, or in this particular case with gases, we're going to go to from moles to volume, because gases can be measured in volume. And we might or may not remember that a 1 mole of any gas at standard temperature and pressure, STP, is equal to 22.4 liters. So that's key, just remembering that 1 mole of any gas, even if it's a small gas or a big gas, at STP is 22.4 liters. Okay, so we're going to use that information to help us along. Refer back to page 9 if you need help with your maps. Okay? All right. So we're going to flip open to page, I think it's 20, let's see, 21 and 20, yeah, 20 and 21. And you're left with this setup here. So it's just how to remember how many particles are in there in 1 mole. So I'll give you a second to make up your mind. How many particles do you think there are in 1 mole? Some of you are like, 1 mole of what? Well, it doesn't matter. It could be a mole of gum. There's going to be 6.02 times 10 to the 23rd amount. Just like if I said, how many particles are there in a dozen? You know that a dozen is 12. It doesn't have to have units. A mole of any substance is this huge number, 602 sextillion. So now we come along, it shows you a nice example problem here. And I'm going to show you how to work number 2. So if we have 4 moles of helium atoms, or 4 moles of helium atoms would contain how many helium atoms? So we start off with what's given, 4 moles helium atoms. I put that over 1. And you remember you put another bar. And then what units go down here? Moles of helium atoms. Now instead of moles, we want just number of helium atoms at the top. We know that 1 mole would be 6.02 times 10 to the 23rd helium atoms. That's our known quantity. So that's going right here. Then we just let our calculator do the magic here. And so on my calculator, as you remember, I try to turn it so you can see it. You type in 4 times and then 6.02. And then notice I'm going to hit the caret button. So let me zoom out just a hair so you can see my calculator. I want you to see that you don't have to hit times 10 to the 23rd each time. You can simply hit second on my calculator, and then you're going to hit the EE button, all right, which for me is the comma button. So I'm going to hit, and you're going to notice you'll get an E right there, and then you're going to hit 23rd. So that represents right there on the calculator, as I zoom back in, that represents 6.02 times 10 to the 23rd. All right, I hit enter. And now I get my answer, which is if I have 4 moles of helium atoms, how many atoms do I have? I have 2.4 times 10 to the 24th. So I'll write that as an answer. Let me zoom in on the paper here. And it would be equal to 2.4 times 10 to the 24th helium atoms. So that's a little review of how to do your standard problems. Now, how do I do gas law problems using the Stoics? Let me show you a couple of those, and then I'll kind of send you on your way to work those through. So if you take a look at number 5, I'm trying to zoom in so you can see number 5. Sorry, this is my first time kind of working with this here. But anyway, if you take a look at 5, it says if you have a mole of neon gas, Ne, occupies 22.4 liters when measured at STP. Remember, STP is standard temperature and pressure. Then, and you've got two different problems. 2.7 moles of neon would occupy what volume? So we take my 2.71 moles, which is given, of neon. I know that 1 mole of neon occupies a volume of 22.4 liters. That's kind of a known quantity. So now I let my calculator do the magic here. I'm going to clear this one off, and I'm just going to do 2.71 times 22.4 liters. And that, if I have 2.71 moles, it'll occupy a volume of 60.7 liters of space. Okay, that's what it'll occupy, and I boxed in my answer there. You notice units cancel out beautifully. All right, let me show you a little more complicated gas law one, and then I'll send you to work on the problems by yourself. So let's take a look. Let's see here. This might be a good one here. All right. I'm going to try number 7 on the next page. So this is page 21, by the way. I'm going to zoom out a little bit just so you can see number 7 right here. I'm going to use this balanced equation to help me along with number 7. So first we got 5 liters of oxygen, and we want to go to liters of ethane. So we're going to go from liters of oxygen all the way to liters of ethane. So we're going from here to here. So let's take a look at how we do that. If we refer back to our mole maps on page, I believe they were page 8 and 9, if you take a look at that, we're going from volume of one gas to volume of another. So in order to do that, I have to do 1, 2, 3, 4 steps. I can't just go across the river here. Remember, there's a shark in there. So you got to use your mole bridge and go across. So it's going to be 4 steps to get there. So now let's see how I work this problem. So we take a look at number 7. I'm going to start off with what's given, which is 5 liters of oxygen over 1. I put liters of oxygen down here because the units got to cancel. And that's going to relate to moles, because you'll notice my next, if you go back to that mole map, I go from liters to moles. We know that the relationship is 1 mole of any gas will occupy 22.4 liters, provided I'm at STP, which I am, times, and then you're going to go from moles of oxygen to moles of ethane, C2H6. If you have moles on top of moles, well, some of you remember what you're supposed to do, and it doesn't. You're not supposed to cover your eyes. You're supposed to use the coefficients from the balanced equation. So you go back up here and you see 7 for oxygen, 2 for ethane. So I'm going to put the 2 here for ethane, 7 for oxygen. Then I'm going to take it one step further. And now I've finally converted to moles of ethane. And now I can get to liters of ethane, which is what I'm looking for. We know that 22.4 liters of any gas is 1 mole. Okay, and now I'm ready to let my calculator do the magic. For those of you that are real strong in math, you realize that if you're dividing by 22.4 and you're also multiplying by 22.4, they cancel each other out. So there's really no need to go ahead and calculate dividing and multiplying by 22.4. So a little trick on the calculator. If I bring this in, so you can see you're going to do 5 times 2 divided by 7. And so you should wind up with 1.4 liters of C2H6. And to be honest with you, I like you thinking about sig figs. So take a look in the problem. You'll notice 5.00 is written like that. That has 3 significant digits. So when I look at my answer, I want to have 3 significant digits. So if you look closely, that last number is a 2, but it's followed by an 8. So I'm going to round that up, and it should be, with correct number of significant figures, I should have written 1.43. So I want to go ahead and change my answer to be 1.43 liters of C2H6 with correct number of significant figures. All right, good luck. That's how you do these gas stoich problems. If you have any questions, see your teachers in seminar or after school.